Hi students, today now the next theory chapter is application of derivatives. In the previous videos you have already studied that what is meant by differentiation and what are the problems and different type of the differentiation. First of all, the polynomial function differentiation, composite function differentiation, and implicit function, explicit function, and inverse trigonometric functions like that. Several type of the differentiation you people have already did in the previous classes or previous videos. I hope you people have already remembered all the differentiation formulas. So differentiation of all the 6 ratios, trigonometric ratios, and e power x, differentiation of the constant, and differentiation of the inverse trigonometric functions, so that you must remember all these formulae, because if you know the formulae then you can easily solve the problems. So now the first application of the derivative is increasing and decreasing. Increasing and decreasing function. When the function is said to be increasing function and when the function is said to be decreasing function. So which function can be differentiated? Suppose I just consider let y is equal to f of x be a real valued function. Be a real valued function. The given function is must be the real valued function. Already know the meaning of real valued function. What is the real value? The range of the function is real number. The range of the function is real number is said to be a real valued function. And what is the real function? Domain of the function is real set or subset of the real set is said to be a real function. Real valued means the range of the function is set of real number or subset of the real numbers is said to be a real valued function. Suppose I just consider y is equal to f of x is a real valued function. Now, or else we can say that x is belong to the set of all real number for all x belongs to R. Now, particular example I just take to better understand the how or what is meant by increasing and what is meant by decreasing function. So let y is equal to I just consider f of x is equal to x square, where x is belongs to R or for all x belongs to R. F of x is equal to x square is that for all x belongs to R, which means that already know that this is the real valued function. That means the range of the function is real valued. So particularly, instead of writing the f of x is equal to x square, if I write y is equal to x square, a particular name, you people already know that what is the name of y is equal to x square or y is equal to 4ax square. It is a parabola. What is the shape of the parabola? It is a upward parabola. Y is equal to 4 or x square is equal to 4ay. X square is equal to minus 4ay and y square is equal to 4x, y square is equal to minus 4x, x square is equal to 4ay form is that, so that it is a upward parabola. So it is upward parabola. The shape of the parabola in a xy coordinate plane is like this. This is said to be the graph of the function. Here I just consider this is the x-axis, origin, negative side of the x-axis, y-axis, origin, and negative side of the y-axis. Now here on the x-axis, roughly I just take 1, 2, 3, 4, 5 like that. Here it is a minus 1, minus 2, minus 3, and here it is a 1, 2, 3, 4 like that. Here it is a minus 1, minus 2. Now observe that and already know that how to draw the graph of the function. Any function f of x is equal to x square, replacing the x value 0, corresponding function value or corresponding y value 0, 0. If you replace the 1 square is 1. If you replace the 2 square is 4, like that it is. Now here I just take the part in this single graph. I just take the parts right hand side of the origin and left hand side of the origin. Observe that right hand side of the origin, as these are all the x values because the x axis is that as the x value is increasing, what about the y value? Y value is also increasing. So that x value is increasing, so y value is also increasing. That means that x is increasing or y value, height of the graph is also increasing. So we can conclude that on the right hand side of the origin, the function is increasing. Right hand side of the origin, the function is increasing. Similarly, left hand side of the origin, as the x value is increasing, minus 10, minus 3. Which one is the bigger one? Minus 3 is the bigger one as compared to the minus 10. So x value is increasing, the y value height is decreasing. So that we can say that on the right hand side of the origin, y is equal to x square is an increasing function. Left hand side of the origin, y is equal to x square is a decreasing function. Here, one more or extensionally we can say the one definition. What is the definition? We can make it here definition. So what is that? First of all, I just consider a let f be the real valued function. It is a real valued function. F is a real valued function defined on an interval. Defined on an interval. This interval is a subset of the real number. Then the function is said to be increasing, decreasing, strictly decreasing, or strictly increasing type. So that on an interval I, suppose if then the function is said to be, then the function is said to be, here is the first one, then the function is said to be increasing. Then the function is said to be increasing if x1 is less than x2. If x1 is less than x2. Here, what are the x1 and x2? x1 and x2 are, suppose if I take 1 is a x1, 2 is a x2. x1 is less than x2, 1 is less than 2. Like that, I am just taking interval is the interval, already know the idea. Suppose a comma b is a subset of a real number. A and b are the any real number. Open interval is that n points are not included. If you consider it is a closed interval a comma b, then n points are included. Obviously, it is a subset of the real number. So that interval, that means in this interval, these two values are belongs. So that I just write for all x1, x2 belong to the given interval I. For all x1, x2 belong to the given interval I. If x1 is less than x2, then we can say that f of x1 is less than or equal to f of x2. F of x1 is less than or equal to f of x2. When we need to say that, whenever it is an increasing function, we have to say that f of x1 is less than or equal to f of x2. That means that. So come to here, I just change that. x1 value is 1, x2 value is 4. Here you can observe that 1 is less than 4. What is the f of 1? F of 1 at x equal to 1, function value is 1. F of 1 is 1. F of 1 is 1. And f of 4, what is the f of 4? F of 4, x value is 4. 4 square, 16 is that. F of 4, 16. 16 is less than or equal to. Is less than or equal to the 16. So that 1 is less than or equal to 16. Can we say that it is an increasing function? Increasing function. This condition is both good. Similarly, the second case. What is the second case? We can say that reverse, or else here one more word is that it is said to be strictly increasing. When we need to say that a function is strictly increasing, means the same condition for all x1, x2 belong to the given interval I. If x1 is less than x2, here it is a strictly inequality. If x1 is less than x2, then we can say that f of x1 is less than f of x2. F of x1 is less than f of x2. In this case, we can say that a given function is strictly increasing. So very clear picture is that, and very simple. Increasing. When we need to say that the given real valued function is increasing, if x1 is less than x2, If x1 is less than x2, then f of x1 is less than or equal to f of x2, slack inequality. The same condition, if x1 is less than x2, then the function is said to be strictly increasing whenever f of x1 is less than f of x2. What is the difference between these two values? Here it is a slack inequality, here it is a strictly inequality. Whenever slack inequality is there, just sufficient to say that it is an increasing function. Whenever strictly inequality is there, in that case it is sufficient to say that it is a strictly increasing function. Now the third condition is, previously we just seen increasing and strictly increasing. The third case is decreasing. When the function is said to be decreasing, the same thing for all x1 and x2 belong to the given interval I. Then once again, if x1 is less than x2, if x1 is less than x2, in all the cases we have to take x values is increasing, x1 is less than x2. Then so we need to discuss that decreasing, so that the function is said to be f of x1 is greater than or equal to f of x2. F of x1 is greater than or equal to f of x2. In that case, the function is said to be an decreasing function. Come to the graph. You can observe in the graph that -1. X value is -1, x2 value is, or x1 value is -2, x2 value is plus -1. So -2, -1, which one is better value? Which one is better value? x2 is a better value. -2 and -1. -1 is greater than -2. Now f of x1 is less than x2 condition is over. F of x1 is 4 is that. And similarly, I just write f of x1 is 4. I just write here f of -2 and f of -1. -2 is less than -1. x1 is less than x2. We need to decide that which inequalities comes here. F of -2 is 4 and f of -1 is 1. Which one is better? 4 is greater. I just write it as greater than or equal to. So if I write greater than or equal to, what it comes? F of x1 is greater than or equal to f of x2. Previously, on taking the observation, we have just taken that left hand side of the 0, the function is decreasing. So function is decreasing. Here slack inequality is there, so that it is only decreasing. In the same manner, fourth condition, that is strictly decreasing. When we need to say that the function is strictly decreasing, once again the same thing for all x1 and x2 belong to the given interval I. If x1 is less than x2, then f of x1 is greater than f of x2. F of x1 is greater than f of x2. In this case, we have to say that the function is strictly decreasing. In this case, the function is strictly decreasing. Out of these four conditions, very simple definition is that you can easily observe that. First of all, observe the common things. What are the common things are there? For all x1, x2 belong to the given interval I in all the four cases. And the next common thing is x1 is less than x2 in all the four. Only thing we have to decide depending upon the f of x1 and f of x2 value. If it is f of x1 is less than or equal to f of x2, then it is a only increasing function. It is strictly less than, in this case it is strictly increasing, and it is slightly greater than or equal to whether it is just decreasing. It is strictly inequality greater than, in this case we have to say that it is a strictly decreasing function. So let us take some graph of this one, or roughly I am just taking for the first case. When or how the nature of the graph is there for the increasing function. Increasing function is nothing but, for example, increasing. In some situation it is equal, because I just written it as a slack inequality. In some values it is equal is that. So observe that here it is x1 value Here it is a x2 value. Here observe that at this point x1 value and at this point in between of these value x2. Obviously x1 is less than x2. X value is here. Suppose it is a 2 where the and it is a 4 is that 2 unit distance or a 4 unit. And observe that f of x1 value, this distance is the same as this distance. So in such cases we have to say that the given function is just a increasing function. And when we need to say that it is a strictly increasing function means the function always is increasing as x values are increasing. Observe that any values are there, any two x values are there which gives the same y value or which gives the same f of x values, no values. So that it is just a increasing function, it is a strictly increasing function in the same manner. Just a decreasing function, decreasing. At some moment, the f of x values are same. It is a decreasing function, and strictly decreasing function means the functions or values of the functions are like this. This is said to be a strictly decreasing function. So very clear on the diagram. It is increasing, strictly increasing, decreasing, strictly decreasing, and definition is very simple. Based on this definition, let's take one example and how to use this definition to the given problem or given function. Okay, let us discuss the first example. What is the given question? Means show that the function f of x is equal to 2x minus 5 is a strictly increasing function in its domain. So it is a strictly increasing function. As we know that strictly increasing means in this manner it is that particularly it is a linear equation. So that f of x is equal to 2x minus 5. So it gives the straight line. Straight line in this manner it goes because linear is the line. Suppose if you consider the f of x as y is equal to 2x minus 5. It is a line involving two variable always represents the, it is an equation involving a two variable always represents the line. So now we need to prove that it is strictly increasing function. As we know that definition, if x1 is less than h2, that is understood. F is a real valued function defined in its domain. If x1 is less than h2, then f of x1 is less than or equal to f of x2. It is just increasing. Strictly less than, it is strictly increasing. F of x1 is greater than or equal to f of x2. It is decreasing function. Strictly greater than further, it is strictly decreasing function. This condition is common for all the four cases. Now, according to this, we need to prove that. So, considering this one, because it is if then Q, if P then Q statement is there. Whenever P statement is true, then only we can discuss about the Q statement. Because you just studied in our first PUC mathematical reasoning. If then statement, if P is true, then Q is also true, like that. So that I just consider. So given f of x is equal to 2x minus 5. So that consider or let consider x1 is less than x2. In all the cases it should be true, because if you consider x1 here, we need to consider x2 as here, so that x1 is less than x2. Taking this one and after simplification we have to get f of x1 is less than or equal to f of x2. So try to get directly, which is not possible, right? What I just do here, x1 less than x2 is that. Here 2x is that. So I just multiply by 2 throughout this inequality. If you multiply, what happens? 2x1 is less than 2x2. After multiplying a positive quantity to the inequality remains as it is. Next, minus 5 is that. So subtracting 5 throughout the inequality remains as it is. So that 2x1 minus 5 is less than 2x2 minus 5. That what is the 2x1 minus 5? 2x minus 5 is f of x. So that 2x1 minus 5 is f of x is less than as it is. Next, can I write this as f of x2? Now, have you got that? x1 is less than x2, then f of x1 is less than or equal to f of x2. Strictly means, so therefore, what is the conclusion? Therefore, f is strictly decreasing function or increasing function. It is strictly increasing function. It is strictly increasing function. This is how we have to show the cases. Yes. Suppose another example, if they given f of x is equal to minus 2x minus 5. If they given f of x is equal to minus 2x minus 5. This function is strictly decreasing function. How? Check it. Once again, according to the definition, we can say that x1 is less than x2. Let x1 is less than x2. Then we have to get that f of x1 is less than x2. Then f of x1 is greater than f of x2 for the strictly decreasing function. So now again multiplied by minus 2. If I multiplied by minus 2, the sign is same as it is. For example, 2 is there, 5 is there. Which one is greater value? Here it is a 5 is a greater value. If I multiplied by minus 1, what will get? Minus 2 is less than minus 5. The inequality remains as it is, or inequality will be reversed? Here the inequality will be reversed. Minus 2 is greater than minus 5. Here also multiplied by minus 2. What happens? Minus 2x1 inequality will be reversed, greater than minus 2x2. Then subtracting by 5, inequality remains as it is. Minus 2x1 minus 5 greater than minus 2x2 minus 5. What is meant by this one? This is nothing but f of x1 greater than f of x2. So I got that required result. If x1 is less than x2, then f of x1 is greater than f of x2. Therefore, in this case, f is strictly decreasing function. In this case, f of x is strictly decreasing function. So here, extension of the definition number 1. This first definition you have already taken. The extension part. Yes. Now come for the theorem number 1. What is the theorem number 1? Let f be a continuous function. F be a continuous function on a closed interval a comma b. On a closed interval a comma b, and f is differentiable, and f is differentiable function on the open interval a comma b. Here one point, just remember, it is always continuous in a closed interval. End points we have to include. Whenever we have to say that differentiability, we have to check that it is a open interval. So already in a CET part or in the previous differentiation, I think you just remember this point. So that continuous means closed interval, end points are included. Differentiable means open interval, end points are not included. Let f is a continuous on a comma b and f is a differentiable on open interval a comma b, then the function f is said to be. Then the function is f is said to be. First of all, it is strictly increasing. F is said to be strictly increasing. When the function is said to be strictly increasing, means whenever f dash of x is greater than 0 for all x belong to the given interval a comma b. For all x belong to the given interval a comma b, or else we can say given interval I. Previously interval is taken, here is taking interval, that particularly a comma b. So if f dash of x is greater than 0, then the function is said to be, it is strictly increasing. Second case, strictly decreasing. When the function is said to be strictly decreasing, means strictly decreasing whenever f dash of x is less than 0 for all x belong to the open interval a comma b, and the third case is a constant function. Third case is a constant function whenever f dash of x is equal to 0. Whenever f dash of x is equal to 0. Very clear. From the definition 1, we have already known that when the function is said to be increasing, when the function is said to be strictly increasing, decreasing, strictly decreasing, depending upon the x1, x2, f of x1, f of x2. In all the four cases, x1 is less than x2, and only thing deciding point is f of x1 value, f of x2 value. Here, in the previous first definition, we have not used the definition differentiation, but here I am just using the differentiation. With the help of the differentiation, we can easily conclude that whether the function is strictly increasing, whether the function is strictly decreasing. For your convenience, I just take one particular example. So strictly increasing means first derivative is positive. Strictly decreasing means first derivative f dash of x is negative. Constant function means first derivative is 0. So you have already known that the first derivative. What is meant by first derivative? Suppose y is equal to f of x be a function differentiating dy by dx. What is the dy by dx? Here I just write as a f dash of x. F dash of x or dy by dx is said to be the slope of the tangent. F dash of x or dy by dx is said to be a slope of the tangent. In our first PUC classes, you have already studied that the first derivative of the function is the slope of the tangent to the curve. Suppose the curve is like this, the slope of the tangent. Suppose the curve is like this, tangent to the curve is said to be the first derivative of the given function. This is y is equal to f of x curve, and this is said to be the dy by dx or f dash of x. The geometrical interpolation also we just did it. So taking the curve in this manner, or you just taken the curve in this manner, here we just taken, and taking the tangent, shifting the Q point here, triangle dy by dx. So that you have already known that. I am just not going to discuss that one. Just remember first derivative of the function, slope of the tangent to the curve. So this is the one thing. So already you just saw, or with the help of the derivative, we can easily say that. In a first example, we just taken that I think f of x is equal to 2x minus 5. You have already concluded that it is a strictly increasing function. Yes, obviously we can say that differentiate f dash of x. What is the f dash of x? Differentiation of the function. Differentiation of 2x is 2, minus 5 is 2. Minus 5 is 0. F dash of x is equal to 2. First derivative is positive or negative? Yes, obviously it is a positive. Positive means what we can conclude that it is a strictly increasing. Previously also we just same thing we have did it. So that either definition number 1 or theorem number 1. So that as compared to definition and the theorem is very easy. And because we are discussing the application of derivative with the help of the differentiation, we have to say that the given function is increasing or decreasing. Based on this one, let us take one more example. Let us prove this one by the help of the theorem number 1. By the theorem number 1, how do you get? So I need a continuous function. Yes, obviously it is a continuous function. It is differentiable. Yes, it is differentiable throughout the real number. And we need to discuss, or we need to come to know that strictly increasing. So strictly increasing means first derivative is required. Get the first derivative. What is the first derivative? F dash of x. Differentiating with respect to x. Differentiating with respect to x. What will get? F dash of x is equal to x cube, x power n differentiation, n into x power n minus 1, 3 into x square, minus 3 coefficient as it is x square, 2 into x, 2 into 3, 6, so 6x, plus 4 as it is, differentiation of x with respect to x is 1, so this is the f dash of x. Now I need to conclude that this value 3x square minus 6x plus 4 is positive quantity for all the real number. Can we say that for all the real number is it a positive quantity? Directly we cannot say that, because suppose if I replace x is equal to minus 10, so can we conclude that is it a positive or negative? We have to simplify, so that, or else if I increase that 100, if I increase that 1000 square minus 1000 square into minus 6, we have to simplify. So it will little bit time consuming. On seeing the function, we have to decide whether it is a positive or negative. So that reason, instead of taking this one, what I just could means rewrite this value. Quadratic equation is that making perfect square. Making perfect square means what? Here 3x square minus 6x plus 4 is that. A plus b whole square. A plus b whole square. What is value? A square plus 2ab plus b square. A minus b whole square. A square minus 2ab plus b square. Here right hand side form is that get into the left hand side form, because any number sum or difference whole square positive or negative value square positive value get. So that reason. So here a value is, what is the a value? We can write this as a 3 or root 3 into x whole square. Root 3 into x whole square. Instead of doing this, one more way is that, or better to do this one, or else instead of making perfect square, here as I take the common. If I take a common as a 3, what happens if I take a common is 3? So x square minus 2x plus 4 by 3 as it is. So 3 as it is. Now a square is that x square minus 2 is required, 2 is already there. A value is x, a square, a value is x. I need a b value or a b square value. Can I write that? 2x as 2 into x into 1. Here b value is 1, so add by 1 square, subtract by 1 square plus 4 by 3 as it is. So here we can easily write that. What we can write? This is a 3 into. So what we can write this value? This we can write as a x minus 1 whole square. So minus outside 1 square is 1 plus 4 by 3. Simplify. Minus 3 plus 4 plus 1 plus 1 divided by 3. Now observe that is for all the real number, this f dash of x is positive or negative. Check it. Whatever the x value you can choose it. X is 0, minus 1 square positive. That 1 square 1 plus 1 by 3 positive into 3 positive. If you replace x value is minus 1000, okay, here also in that case also it is a positive. So that now we can easily say that f dash of x is greater than 0. If once you got f dash of x is greater than 0, what is the final conclusion? F of x is strictly increasing. F of x is strictly increasing function. This is how we have to show that. So there are different ways are there to simplify that, but on looking at given function or this value, final value or f dash of x value, we have to directly say that it is a positive quantity, unless at this moment we cannot say that it is a positive. Obviously we get it as a positive, doesn't matter, but we have to prove in this manner. So the remaining problems we will discuss in the next video.